Hi, my name is Josiah Fon from Liberty University, and this is the second part of a series about my capstone and FarmBot's weed detection software. This video will go over the installation of Darknet, which is an open source neural network. The Darknet repository they'll be using is under LXCAB. This is a more updated version compared to the original and has active contributions still being made. As we scroll down from this repository, we can see the requirements and how to install dependencies. And we can see a list of all things that are necessary in order for Darknet to actually run. The first thing you'll need that's not even listed here and it's kind of assumed to be already on a system is Visual Studio's either 2017 or 2019. You can get that through visualstudio.com, Visual Studio Microsoft.com, and the older downloads. And you should be able to find either 2019 or 2017 if you do not already have it on your system. The one I'm currently running is 2019 community version. And the next thing that we'll need is CMake. This one has 3.18 listed. I was able to make it work with 3.19. And so as we go to that link and scroll down, we can see that there are older versions here. If we click on this link, and we can scroll to what version that we're looking for, 3.18 and 3.19, 3.19 in this case. And depending on the operating system that you are running, since I'm running a Microsoft Windows, I chose the Windows 64 MSI version. And there are other ones such as TARS or for Mac OSs or Linux systems. You can also download those. And clicking this link will run, and you can have an installer. And you can click through this and make sure that it's installed where you need it to be. Next thing we'll need is CUDA. Here we'll follow this link. We're going to follow this version 10.2. As we scroll down, we can see version 10.2. Click into that, and we can choose what operating system we are working with. I'm on Windows 10, and I want a local version to be installed. The only thing we really need is the base installation. You can have the next two patches as well, but those are not necessary for running Darknet. And the next we'll need is OpenCV. If we follow this link will be broken. We can fix it by removing the .html at the end. I am currently running OpenCV version 4.9, and that was able to successfully work and run Darknet. If we click this Windows link here, it will download an installer. And now we want the CU DNN. We want version 8.0.2. As we scroll down, we notice that there are actually three versions of 8.0.2. The one that we want is the one that correlates to the CUDA version we downloaded, which is 10.2. And here I'm running Windows 10, so I'll click this installer, and I'll have a zip. We can find the documentation of how to actually integrate it, because this file is just the zip is just several files that you have to unzip into where you installed CUDA. We can find those instructions here. Since I'm using Windows, I'll click on this one here, overview, and this will give more information on how to install CUDA properly on Windows. So here it's Linux, and now we can click on Windows, and this will give a full step-by-step guide on how to properly install this onto Windows. And those are the software needed in order to run Darknet. So now what we will do is actually install Darknet and get the file made into an executable. If you follow along the last video, you should already have Miniconda installed and environment already made. Here, I'm going to activate the environment I made last time. If you do not know how to create one, you can create a new environment by with this line and then whatever name you'd want here. Since I already have one, I'm just going to go into the Jupyter. Activate Jupyter, and then I'm going to change directory I'm in. And so if you follow along last video, you should already have my Capstone 2324 repository downloaded, which has these files. The file we'll be needing is this one up here. So we go into here, and then we go back into Capstone 2324. And then now we can see here that we are in the right directory, and I'm going to run Jupyter Labs. And I want to go into the Traniolo v3. If you have CUDA properly installed, this line should send the correct output. This is seeing that you have a GPU installed and what version, give more information about that. And then also, the next thing we want to do is clone the Darknet repository into a folder named Darknet. Darknet already exists, so it's not going to make a new one. We're going to go into Darknet, and this next line is going to change some settings. So this is going to activate change from OpenCV0 to OpenCV1, change GPU0, GPU1, CUDNN0 to CUDNN1 just to activate it in the makefile. So now that that is done, next we want to run is OpenCMake. You should have something like this. This will probably be empty. I'll look for the source of where I have that directory of Darknet I just made. It's in demo, Capstone 2324, and in Darknet, I'll select that folder, and then browse build. I'm just going to want to put it in the same spot. Select folder, and then I'm going to click configure. This will, if you have Visual Studios installed, this should pop up here. Select the version that you have, 2019, x64. By default, it will use x64, and hit finish. This process might take a little bit, but at some point, and here we go. So the only things that are necessary, you might have some errors here. So the one that we want to look for is UDNN library not found. This is one that I get most of the time. So here we can find this missing library DLL. If we go to where we installed CUDA and CUDA-NN, so here it is in the NVIDIA GPU Computing Toolkit. Open up into that, go into CUDA, run 10.2, and library 64. Version link for is CUDNN 64.8.lib. And we want to put this in 64.8.lib. And now we hit generate. The generating is now done, and we can open our project. This will open Visual Studios. First thing we want to do is go into the configuration manager under build, change this to release 64, release. Make sure that this box is checked, which is install. If we hit close, we hit build again and build our solution. So here we can see that successfully builded all 7 of which we wanted to build. We can close out on Visual Studios, close out a CMake. Now that we're back in the Jupyter lab, we can continue running the rest of these lines. First one I want to run is copy the YOLO v3 configuration to YOLO v3 training. The YOLO v3 training is the configuration file that we will be editing. We can run that. And this is where we'll make the changes to the YOLO v3 training configuration. Here we can see some calculations of how we would do that. So the first is our class number. In our example, we're going to be using class of 3, and max batch is going to be 3 times that. So 3 times 2000, and our filter number is going to be classes 3 plus 5 times 8. That's going to be 24. You can see that this is where the filter changes are being made from 255 to 24, as well as max batches is set up here, classes are being set here, and the steps is max batches times 0.8 and max batches times 0.9, which should be written down here. Now we're going to make a folder called weights. This is where our backup is, and as our Darknet is training, it's going to send the weights it calculates into that folder. Weights already exists, so it's not going to do anything. I'm going to copy classes v1.text into data object.names. And here we're going to copy the Python folders from capstone 2324 into Darknet, and then we're going to run them afterwards. So if we look at inside of create object data, we can see that it creates a file there and then it writes this line into it. The first thing we see is that class is equal to 3. You can leave the rest of these alone except for the very end. If you want to change what folder you're writing your weights into, you can change that into a different folder from backup. Right now I have it set to the weights folder I made earlier. And then make directory data object. This is where we're going to put all of our images that we want to train with. And then now we're going to run this line, which is the weights Darknet model. We can see that it's busy right now, should be installing. See, this bar is loading. See, that is now finished. And so I have a folder of images.zip. I'm just gonna kind of unzip that into data object, so it's not currently there, but now that should be fine. Perfect. And I'm going to do the same thing with create train. What create train does is it links all of our images and it puts into the train.txt file. And so now when we run our Darknet model, it's going to be able to know where to find all of those images. And this is the line to run Darknet. It's hard to see if you run it inside of Python. So if I take my command prompt and then I move into where this directory is, so cd memo slash capstone 2324 slash darknet. Let's see. Here, capstone 2324, and I run this line. The options we have is Darknet. This is the executable, detector train, data slash object data. This is our configuration, and this is our Darknet 53 model that we use to train. This is a common error. Oh, I forgot to run this line. If I run this line here, I go back into this line. Now we can see that we are properly training our model. And for reference, I have a finished one in a different project. So here, this is a different project that I had made before to test everything. And inside weights, there are 6,000. It goes up to 6,000 because that was the max batches we made, which was 3 times 2,000. And there's final, which is the very last one it made, and last. And so as it's being made, it'll first make 1,000, 2,000, 3,000, and last kind of follows along all of them at the same time. So every 1,000 it'll update and create a new one, but it'll still be continually tracked in last. And final will just be the last one and the same as 6,000. And so that is how we can make our object detection model. The next video, we will talk about how to use that detection model in order to actually detect objects in a program.